Hello students, now next topic which is temperature, stress and strain. Okay, now temperature stress मतलब क्या है? एक रॉड है, इस रॉड को क्या क्या है, एक साइड से फिक्स किया है और एक साइड में क्या है, फ्री है. ओके, फ्रॉम दिस टू दिस इज आवर ओरिजिनल रॉड. ओके, एक साइड से फिक्स है और एक साइड से फ्री है. ओके, मैं यहाँ से क्या हीट कर रहा हूँ, जैसे हम रॉड को हीट करने वाला हूँ ना, वहाँ पे क्या होने वाला है, रॉड क्या होगा, हीट होगा. जैसे रॉड हीट होगा, रॉड अपने आप क्या होगा, आफ्टर सम टाइम रॉड क्या होगा, रॉड का एक्सपेंशन स्टार्ट होना चालू होगा. ठीक है, जैसे रॉड का एक्सपेंशन स्टार्ट होगा ना, वो एट अ सर्टेन लेंथ के लिए उसका क्या होने वाला है, चेंज इन लेंथ. मतलब उसका लेंथ क्या होने वाला है, इंक्रीज होने वाला है. तो पहला रॉड का लेंथ इतना था, थोड़ा हीट करने के बाद वहां पे चेंज इन लेंथ कितना होगा, इतना होगा. तो वहां पे हमें चेक करना है टेम्परेचर स्ट्रेन क्या रहेगा. यहाँ पे टॉपिक क्या है, टेम्परेचर स्ट्रेसेस एंड स्ट्रेन. तो यहाँ पे क्या है, टेम्परेचर स्ट्रेन कैसे कैलकुलेट करने वाले, स्ट्रेन का फॉर्मूला बेसिक, चेंज इन डायमेंशन अपन ओरिजिनल डायमेंशन. ठीक है, यहाँ पे चेंज इन डायमेंशन मतलब क्या है, L into अल्फा into T divided by original dimension that is called as L. ठीक है, यहाँ पे चेंज इन डायमेंशन L into अल्फा into T क्यों लिखा मालूम है, क्योंकि पहला ओरिजिनल लेंथ तो L था. ठीक है, और लेंथ किसके वजह से चेंज हो रहा है, बिकॉज ऑफ थर्मल एक्सपांशन, बिकॉज ऑफ थर्मल एक्सपांशन, कोएफिशिएंट ऑफ थर्मल एक्सपांशन. मतलब हम थर्मली यहाँ पे क्या हीट करें, इसके वजह से उसका लेंथ क्या हो रहा है, चेंज हो रहा है. तो दैट इज कांस्टेंट इज कॉल्ड एज अल्फा, दैट अल्फा इज कॉल्ड एज कोएफिशिएंट ऑफ थर्मल एक्सपांशन. और यहाँ पे T स्टैंड फॉर टेम्परेचर, कितने टेम्परेचर से वहां पे इंक्रीज हो रहा है, मतलब अगर 1 डिग्री सेल्सियस में कितना लेंथ आगे बढ़ रहा है. ठीक है, 2 डिग्री सेल्सियस जब हो रहा है तो कितना लेंथ आगे बढ़ रहा है. ठीक है, दैट इज कॉल्ड एज टेम्परेचर. तो यहाँ पे चेंज इन लेंथ आ गया L into अल्फा into T डिवाइडेड बाय ओरिजिनल लेंथ. इट मींस चेंज इन डायमेंशन, इट मींस कितना लेंथ था, कितने टेम्परेचर के ऊपर उसका लेंथ क्या हो रहा है, चेंज हो रहा है. मतलब विथ रिस्पेक्ट टू टेम्परेचर उसका लेंथ चेंज होना स्टार्ट हो रहा है. ठीक है, दैट्स व्हाई अल्फा इनटू टी कम्स. नाउ ओरिजिनल लेंथ व्हिच इज कॉल्ड एज L, नाउ LL गेट कैंसल, द रिमेनिंग टर्म व्हिच इज अल्फा इनटू T. देयरफॉर फार्मूला फॉर टेम्परेचर स्ट्रेन व्हिच इज इक्वल टू अल्फा इनटू T. ठीक है, नाउ वी हैव टू फाइंड आउट टेम्परेचर स्ट्रेस. तो टेम्परेचर स्ट्रेस का फॉर्मूला क्या है, सबसे पहला सिंबल है स्ट्रेस डिवाइडेड बाय सिग्मा, TMP स्टैंड फॉर टेम्परेचर. ओके, नाउ वी नो दैट हुक्स लॉ, कैपिटल E इज इक्वल टू सिग्मा अपॉन स्ट्रेन. ठीक है, नाउ हियर वी हैव टू कैलकुलेट टेम्परेचर, दैट्स व्हाई आई एम राइटिंग हियर टेम्परेचर. नाउ वी हैव टू फाइंड आउट टेम्परेचर स्ट्रेस, then multiply this temperature strain here, then we got formula for temperature stress. The formula which is got temperature stress is equal to modulus of electricity into temperature strain. Okay, this is the required formula you have to learn. Okay guys, now whereas the topic which is L is called as original length, where L is called as original length. Next, alpha is called as coefficient of friction, sorry, coefficient of thermal expansion or contraction by per degree Celsius. Expansion or contraction per degree Celsius. Okay, it means the per degree Celsius को क्या बोलते हैं, that is called as per degree Celsius को इसको कैसे लिखते हैं, divided by, मतलब 1 upon degree Celsius, that is called as per degree Celsius. Okay, this is the symbolic representation. मतलब डिग्री सेल्सियस कहाँ पे रहता है, डिनोमिनेटर में रहता है, तो that is symbol of alpha. Now whereas T is equal to temperature. Okay, its symbolic representation which is degree Celsius. Okay, if degree Celsius present in denominator then it is called as alpha. If degree Celsius present in numerator, directly you know the temperature of that unit. Okay, so this is the basic theory. Thank you. Now questions on temperature, stress and strain. Question number 1, which is a rod is 2 meters long at 10 degrees Celsius. Find the expansion of the rod when temperature is raised to 80 degrees Celsius. If this expansion is prevented, find the stress in the material take capital E is equal to 1 into 10 raised to 5. Alpha is equal to 0.4 times 0, 12 per degree Celsius. This is a symbolic representation of alpha. That alpha is called as coefficient of thermal expansion or contraction. Okay. Now, first of all, sort out given data. Given a rod is 2 meter long, that is length 2 meter. Convert it into mm, that is 2000 mm. At a 10 डिग्री सेल्सियस, मतलब एक रॉड है, हमने एक साइड से फिक्स किया है, एक साइड में फ्री है, एक साइड से फिक्स है, एक साइड में फिक्स है और एक साइड में क्या है, फ्री है. उसका टेम्परेचर फर्स्ट टाइम कितना है, 10 डिग्री सेल्सियस, मतलब T1 दिया है 10 डिग्री सेल्सियस. नेक्स्ट, find the expansion. So what we have to find the expansion, that is called as a delta L. Okay. When temperature is raised to 80 degree Celsius, मतलब T2 दिया है 82 degree Celsius. Okay. Next, if this expansion is prevented, मतलब जो expansion जो हो रहा है वो prevent किया है, इसका मीनिंग हम डायरेक्टली सॉल्यूशन में स्टार्ट करेंगे. Find stresses in the material. First, our aim is to find out change in length. Second aim is to find out stress in the material, that is we have to find out sigma. Capital E, which is given 1 into 10 raised to 5 Newton per mm square. Alpha, which is given 0.4 times 0, 12 per degree Celsius. Okay. Now solution, which is solution में क्या हम find out करें, सबसे पहले डेल्टा एल फाइंड आउट करा. तो डेल्टा एल फॉर टेम्परेचर स्ट्रेस, आपको ऐसे मालूम पड़ेगा डेल्टा एल के लिए यही फॉर्मूला यूज करना है. डायरेक्टली मैं क्वेश्चन में समझ में आता है. रॉड इज 2 मीटर लॉन्ग at 10 डिग्री सेल्सियस, मतलब क्या उस रॉड को 10 डिग्री सेल्सियस में हीट किया. तो रॉड को हीट किया मतलब वो कौन से किस में आया, टेम्परेचर स्ट्रेस में आया, स्ट्रेन में आया. तो यहाँ पे टेम्परेचर स्ट्रेस के लिए फॉर्मूला क्या था, डेल्टा एल का. सो वी नो दैट डेल्टा एल इज इक्वल टू एल इंटू अल्फा इंटू टी. So we also know the L, we also know the alpha, but we don't know the T. We know the T, but there are two T, means T1 and T2. So what we have to find out? First of all, this T is called as average temperature. Okay? Here we are giving two temperature, T1 and T2. So that's why calculate average temperature. T is equal to T2 minus T1. That T2 which is 80 minus T1 which is 10. That T will go at 70 degrees Celsius. Now we also got T. We know the value of L, that is length. We know the value of alpha. We know the value of T. To substitute this value, you will get L delta L. So here, therefore, delta L is equal to value of L, which is in mm, 2000 into alpha, which is 0.4 times 0, 12 into T, which is 70. Multiply this all term, you will get 1.68, which is in mm. That is called a change in length. Okay. Once we get change in it, our first approach is completed. Now we have to go for stress. We know capital E is equal to sigma upon small e. Okay. So you can calculate from this formula directly. You can calculate stress formula. That stress formula which is, this is the no need of derivation. That stress is equal to alpha into T. We already discussed. Okay. Now calculate this, which is alpha into T into capital E. Okay. Now otherwise we have to discuss. Then the capital E is equal to stress upon strain. That strain which is equal to change in length upon origin length. That strain formula we already know. Capital E is equal to sigma upon alpha into T. This is the formula of alpha into T, which is the formula of strain. Now we have to find out sigma. So now we can, how can we get E into alpha into T is equal to sigma. Put the value of E, which is 1 into 10 raised to 5. Put the value of alpha, which is 0.4 times 0, 12 into, substitute the value of T, which is 70. 70 is equal to sigma. Calculate this total multiplication. You will get sigma, which is 84, which is unit Newton per mm square. Okay. So this is the formula question related to temperature stress. Thank you. Question number 2, which is a rod 300 mm long, 20 mm in diameter, is heated through 100 degrees Celsius and at the same time pulled by a force of P. If the total extension is 0.4 mm, what is the magnitude of P? take capital E, which is equal to 2 into 10 raised to 5 Newton per mm square. Alpha, which is given 12 into 10 raised to minus 6 per degree Celsius. Now given data, which is a rod 300 mm long, the length which is given is 300 mm, diameter which is given 20 mm, is heated towards 100 degrees Celsius, the temperature which is given as 100 degrees Celsius, and at the same time it is pulled by a force of P. That means we have to find out the value of P. We don't given the value of P. Now if the total extension is 0.4, that is delta L, which is equal to 0.4 mm. What is the magnitude of P? To find the magnitude of P, take capital E is equal to 2 into 10 raised to 5 Newton per mm square, and alpha, which is given as 12 into 10 raised to minus 6 per degree Celsius. Okay, so we have to find out the value of P. The solution, now first of all we have to draw the diagram of rod which is already heated and it is also pulled by a force P. Okay, now we have to know, we know the value of L, diameter, temperature, delta L, capital N, alpha. We have to find out the value P. Now change in length, it is the occurs at because change in length due to elongation plus change in length due to temperature. तो यहाँ पे क्या हो रहा है, जैसे हम हीट करें उसकी वजह से चेंज इन लेंथ हो रहा है, और जैसे हम फोर्स अप्लाई करें उसके वजह से भी क्या हो रहा है, चेंज इन लेंथ हो रहा है. That's why we add this to change in length. Now change in length for elongation, which is delta L is equal to PL by AE. Okay, we know the value of L, we know the value of area, we know the value of capital E. We can calculate area with the help of diameter. Okay, now this area which is equal to pi by 4 d square. Okay, put directly value in this equation. Now what is the value of P? P we have to find out. P remains as it is. Value of L, which is 300, divided by area, which is pi by 4 d square. Okay, into capital E, which is 2 into 10 raised to 5. 2 into 10 raised to 5. P remains as it is, 300 into that 4 is in numerator, reciprocal will occurs. Now pi into diameter value, which is 20 square into 2 into 10 raised to 5. Calculate this elongation, you will get change in elongation, which is 4.74774 into 10 raised to minus 6 of P. That P remains as it is. Now you have to calculate change in length for temperature. Change in length for temperature, which is equal to L into alpha into T. L, which is given as to 300, alpha, which is given as 12 into 10 raised to minus 6. 12 into 10 raised to minus 6. Temperature already given, which is 100. Okay, calculate this value, you will get change in temperature, which is equal to 0.36. Okay, now substitute this value in this equation. Let us consider this equation, which is 1. Therefore equation 1 will be change in length is equal to change in length for elongation, which is 4.774 into 10 raised to minus 6 of P, plus change in length for temperature, which is 0.36. We already given change in length, total change in length we already given, that is 0.4. We substitute here value. 0.4 is equal to 4.774 into 10 raised to minus 6 in times of P plus 0.36. Now we shifted 0.36 to the left hand side, it becomes 0.4 minus 0.36. On right hand side, 4.774 into 10 raised to minus 6 of P. Calculate this answer, you will get something subtraction. On right hand side remains as it is, 10 raised to minus 6 times of P. Now we have to calculate the value of P. Hence 4.774 into 10 raised to minus 6, it is in multiplication. When it is shifted to the left hand side, it is being dividation. That is 4.774 into 10 raised to minus 6. Now take the ratio, you will get the value of P. That value of P, which is 8378.72, which is in Newton. So we will get force applied on a bar when it is heated, at the same time it is pulled by a force P. The value of force which is 8378.72 Newton. Okay, so this is the end of our first lesson. Now we meet in the next lecture.